In this tutorial, I'm going to show you how to do measurement in Region Inspector in ImageMatrix. So right now I have open an area and with the Region Inspector, and you see there are tools in the measurement panel. I can do line measurements, I can do angle measurement, and um, so and I have to do other measurements. I'll show you later. So first, this is a sample of protein DNA complex. So the line shape particle is the DNA, and the round shaped particle is the protein. And as you see, there are some proteins that are bound to the DNA. So first, measurement, line measurement. So to do the line measurement, the easiest way, for example, if I want to trace the DNA, the easiest way is to let the computer trace the DNA automatically for me. So to do that, we have to mask the DNA first. So I click mask, and as you see that you can adjust the mask so that the DNA can be masked fully. So once they are masked, which means they are connected by the mask, you can check back and forth to make sure that the DNA are fully masked. So once the DNA is masked, you can then click the DNA. The program automatically traces DNA for you. And click another DNA, it will trace the other DNA. So here is some convention here. And once you click the DNA and the program makes the trace, you see the profile in the axis on the right bottom corner. So this is the profile of the DNA trace. And the direction of the trace is determined by the end point of the DNA's trace on the image. The block represents the starting point of the profile, which means that this point at the beginning, the 0 point, is where the block is. And the end of the trace, the circle, represents the end point of the profile. So after there are multiple ways to trace the DNA. So this is the simplest way, is simply to mask the DNA and just click the particle. The other way to do it is to use the joins function. So this gives you some flexibility so you can determine which way the trace goes. So as you see in this particle, there are two colors. The red color represents the mask, and the green color represents the DNA skeletons, or the fiber skeleton, what I call it. So I call it fiber. And the fiber is the thinned version of the mask. To trace the DNA using the joins function, this is only a simple example, but for a more complex example, the automatic tracing function does not work well, and you have to use some other function, for example, like using the joins function. So in this function, you can manually trace the DNA by simply connecting the joints in the fiber. So let's go ahead. I click joints, and so all you need to do is to pick up the joints. Usually we start from the starting point, so you have to be careful. You need to place the joints at where the green line is. So for this DNA, it's pretty simple. You can just simply click the starting point and click the end point, and that should finish up for you. So it automatically connects the two joints using the shortest path. So that works well. And if you want to undo this, the last joint, you can just simply press the backspace key, And for example, I can do this. I can place joints at where the protein is, and then I can go to the next joints, and then I can go to the last joints. So as you see, I place like several joints, and each segment between two joints, they are represented by a distinctive color, which is there are correspondence between the fiber that are traced in the image and the profile. So this is pretty useful if the DNA molecule is complex. If, for example, it's circular, supercoiled, or if the DNA tangled with itself, and which results in the arms cross the other arms. In that case, the automatic trace won't trace the DNA fully. In this case, you have to use, you can use the joints, which you can manually determine where it goes. So that's a useful function. So after you have done this, you simply middle click to finish. Yes. So so this is the other way to trace the DNA. The third way to trace the DNA is to use the freehand function. Or you can use the line function if the DNA is pretty straight, but you can use the freehand function. So this is useful if the DNA is extremely complex. So even the joint function, you have to have the skeleton lines, like that should be aligned with the DNA. If, for example, the image is noisy, then your mask and your skeleton line could be screwed and they might not align with the DNA perfectly. In that case, I would use the freehand function. So this function is best used to do it without a mask. So I can just cancel the mask and then click freehand. So this is especially useful if you have a digitizer pen, like some of the tablet PCs. So you can use your pen to trace the DNA. Of course, you can use a mouse using a Wacom tablet as well. So just use your pen or your mouse and just click and drag the line and trace the DNA manually. This can be done pretty quickly once you have mastered it. So, and you can see the DNA is traced well, and you can see the profiles. There are some differences between the automatically tracing and the manual tracing. I discussed those differences in the text of the instruction. So this gives you a profile, and you can actually move these ones. And you can also do a line section measurement, like that. You can, of course, draw multiple lines or freehand lines. These all give you the profile section. If you want to overlay these profiles, you can do is you can say add to section overview. Just right-click this. It should pop up a new window for you, and apparently for some reason it does not pop out that for me. Oh yeah, there you go. So I guess that's, yeah, it's the screen recorder issue, so it's kind of slow, but it's not so in the real case. So just keep in mind. So right now, add this to a section. So this is basically the same as the section measurements that I discussed in the tutorial in the image measurement section in the image processor. So it's the same thing. I'm going to skip this part. So yeah, you can simply click the DNA and they trace it for you. And remember, you can only trace the DNA if you click where the mask is, like that. So if there's no mask, you cannot click DNA. So, but if there is a mask like that area, then click it, it will trace it. So right now I'm going to do some measurements. So for protein DNA complex, I want to know where the protein is. Apparently that's identified by the peak in the profile here. The protein is usually taller than the DNA, so I can see two peaks, which represents two proteins bound on the DNA. That's exactly what shows up here. So all I need to do is to use the profile, and there are multiple ways to record the position. You can either record it by simply right click the protein peak and say record position, or you can do so that's easy. You can click multiple places, right? You can also do is you record position at a designated location. This can be the designated location can be anything that's specified in the options here. So right now it is the maximum height. So if you click this one, it should mark that point because that's the maximum height there. So there are other ways to do this. Let's do first. As you see that when I mask this, yeah, I already make two markers there. That represents the same thing as I mark the position in the profile. I can show you again. So what I'm going to do is I'm going to just clear the markers first, and I do it again. So this time I'm going to do record position using the section function. So this will mark the peak after the horizontal line here. So just click that. And if I'm not satisfied, I can click again, then it will mark that peak, right? So you have to carefully choose the level, and the program will determine the peak above that level. And then middle click to finish. So right now, this is useful if you have multiple peaks around this the profile. You want to identify them in the as quickly as you can. So you just one click identify them. Apparently, you can specify the options of your stuff of these position, what kind of position you want to measure. So all you have to do is you click options, and you can say what kind of position I want to measure. For example, right now I'm only tracking the total length and the current position, and once you make the measurements of position, the results are shown in the dashboard there. So you see the position, total length. If you want to make measurements of other parameters like short arm length, long arm length, the definition of those parameters, I would discuss that in the text section. And so, and the record position at desk and location can define, so it's default to maximum height. You can define that as the minimum height or any kind of positions. Or you can even define the position as specific height. So make these measurements apparently they're duplicates because I made the same measurements twice. And if you don't want, so this is a table. So this is a core dashboard. It basically records all your parameters. It will be shown up here, and you can play with the table. For example, you can do is maybe I should discuss that in the record section. I mean, in another tutorial. So I'm not going to discuss how I'm going to do with the table. Basically, it's like a mini Excel sheet. You can like delete rows, delete columns, or clear the table, and make a new spreadsheet, right? So, and right now it has just a blank spreadsheet. I haven't make a new one, so it's not recorded. I'll discuss that in the record measurement tutorial. So right now I have done these line measurement. The next thing I'm going to discuss is the angle measurement. So I use that angle measurement to determine angles, especially the DNA band angles, where the protein is. So it can be used in other applications where you want to measure the band angles. So in this case, I just click band and draw, angle, and then I have a crosshair cursor, and then you can trace the DNA that's coming out of the protein. And after you've done that, you see you can adjust the arms like two ways. You can adjust either way. So and again, you can see that you have this band angle label there. You can adjust its appearance using the text, and I've discussed that before. Yes. So it's basically the same thing as when you adjust the appearance of the particle selections. They have these number labels. This I attribute them all as labels, so you can adjust their appearance. So right now it's like 89 degrees. So if you want to add these measurements to the table, yeah, I'll discuss the recording later, but to add the measurements in row 1, you have to click a cell in the row. It's basically select that row. If you don't click any cells, then the measurements will be added to the as a new row in the end. So in this case, I just select the first row and then right click this angle and say add to angle 1. So right now I have the angle already added, as you see, and you can do the same thing for the particle too. So so one thing to keep in mind is when I click the particle, see there are two markers there. So there's a brown color and there's a green color. So this color order is always the same. The first color is brown, the second color is the green, and the third color is light green. So the markers will represent the same color as when you mark the peak. So I mean, if you remember, there's a brown color marker in the first peak, and there's a green color marker in the second. So the color order is the same, and so the color will give you an idea of what the order of the peak appears. So apparently the brown will appear first. That's because the brown is close to the starting point of the fiber. The starting point is the block, if you recall that. So that means that the brown is the first measurement and the green is the second measurement. And that represents the same sequence in a table. The first row will represent the brown and the second row will represent the green. So because there's a duplicate measurements on the 3 and the 4 because I make twice the same measurements, so I should really delete them for now for simplicity. So all I need to do is just select two cells and use control click to select multiple cells. So I have to select two rows, and you can right click the table and say delete row, and that's get rid of them. So yes, so I measure the angle, and you can also measure the distance. It's basically a line, and then they'll tell you the distance between them. So this is useful if you have the define the pixel scale. And so this measures the real-time, real-world distance, not the kind of distance that's only pixel distance. So for example, if I just do this, it should be in 100, let's say 100 nanometers, so that should be the real world distance. You can check that by just click the axis label. So in this case, so you see, it looks like for this image, the 200 nanometer is pretty much the same as the pixel distance. Oh, not really. So see that. So this is actually the pixel distance. So you see pixels, and real world measurement that would be represent 4.2, 420 nanometers. So that's 100 pixels and 420 nanometers. So and yes, and so once you have, for example, you can move the second line. So let's do this. You can also take measurements by so we already know there's 3 ways, right? 1, 2, 3 in this manual to measure the position of the peak. You can also do is you can click the position here. That will insert a new line in the table. If you want to replace the position measurements in, for example, in line 1, you can just simply select that row. Just click any cell in that row. So then you say position, click that, and then you can check a position. Now as you see that the measurements in the row 1 is already been replaced by the new numbers, and you can do another row. This will replace the second row, and if you continue that, you will add a third row. So this time it's right click to finish. Yeah, I should really do a middle click to finish. I would remember to check that. So let me write down something. Because right click always triggers the context menu, which I don't think is elegant. The middle click is fine. You can use shift plus click to simulate middle click. If, for example, if you're using a touchpad which does not have a middle click, you can use shift plus left click to simulate the middle click. So I think that's pretty much for the measurement. Stay tuned.